In this video, we are going to look into what is 3-address code with few examples. So first of all, 3-address code is very simple. It is an intermediate representation in our phases of compiler. So in our phases of compiler, the first phase of compiler is intermediate code generation. So we have various forms of intermediate code generation. So one among the various forms is our 3-address code. So here I am just taking a simple example, which is A is equal to B star C. So this particular statement A equal to B star C can be represented with 3 operands. That is, for example, say this B star C is a function, that is we have to multiply B with C and the result should be stored in some other operator. So here we will be using few temporary registers for performing this particular function. So here B star C, this is the operation. I am doing this operation and I am storing the result in one temporary register named T1. So here why it is named 3-address code is very simple. So here we have B as one operand and C as one operand. So and the result is stored in another one. So 3-address code is that which uses 3 operands, that is 2 for its input and 1 for its result. So at the maximum it can use 3 operands. So here B and C are its inputs and the result is stored in another operand, which is T1. And now this particular result is stored in A variable. That's all. So here one operand is being used and another operand is used for storing the result. There is one input and one output. In the first line 2 inputs and 1 output, and in the next line 1 input and 1 output. So at the maximum 3 operands will be used in order to to perform any statement what is given in any language. So here this 3-address code can be implemented in various ways. That is, there are 3 specific ways for implementation. So one is Quadraple, which uses 4 fields as the name indicates, quad, and next one is Triple, which uses 3 fields for this implementation, and next one is Indirect Triple, where pointer plays a major role. So first we will see a simple example, and for that example first we will write 3-address code, and followed by 3-address code we will see what is Quadruple implementation and triple implementation. So I have taken an example A equal to B star minus C plus B star minus C. So here minus C is nothing but unary minus of, that is unary operator, unary minus of C. So that is the first function what we have to do. So I am just doing the unary minus of C as the first operation. So minus, or it can be unary minus in words, minus C, and this result I am storing in a temporary register T1. And here say one input operand and one output operand. And now minus C result is stored in T1. And this result should be multiplied with B. So B into T1, I am storing the result in T2. That's all. And now I have completed this particular function. So this function answer is in T1 and this function answer is in T2 register. Similarly, I am going to do this particular operation. So minus C, I am using another temporary register, say T3, has the result minus C, and T3 result multiplied by B, so T4, I am using another temporary register to store this particular result. So now this overall, this result is now stored in T4. So now we have to sum this T4 with T2. So T2 is summed with T4. Now I am storing the result in another temporary register, say T5, and this result is to be now applied to A identifier. So the result of T5 is assigned to A. That's all. So this is our 3-address code. So this can be implemented in 3 ways, that is Quadruple, Triple and Indirect Triple. So first we will see what is Quadruple. So Quadruple uses 4 fields which I have listed here. This is operator, OP represents operator, argument 1, argument 2 and result. So we will take this particular 3-address code and see how it is being implemented in our Quadruple form. So in the first line, say minus is the operator. So in operator field enter minus, and we have only one input, so one argument, which is C. In argument 1 enter C. Now the results is stored in T1. So I am writing T1. In next line you take the operator is star, multiplication of argument 1 is B, argument 2 is T1. So B and T1. Result is stored in T2. So T2. In the next line, similar to the first line, the operator is minus and argument 1 is C. The result is stored in T3. Next line we consider it is similar to the second line. Operator is star. First operand, that is argument 1 B, argument 2 T3. Result is stored in T4. That's all. Next line, plus is the operator and T2 is the argument 1, T4 is argument 2. So T2, T4, and we save the result in T5. And in next we have just only assignment, and here what plays the major role as operator is equal to, since we are assigning the value of T5 to A. So operator is T5 and T equal to, and T5 is argument 1, and we are storing the result in A. So the result is stored in A. That's all. This is the quadruple implementation. So for each and every result, we'll have some reference. So that we will be representing with 0. So first result is stored in 0, next 1, next in 2, next in 3, next 4, and next 5. That's all. Next we'll consider triple. In triple, we are not going to use the temporary registers. The result column is not there. We have operator, argument 1 and argument 2. So how we'll be retrieving the result is help of the references what we have here. So I'm just listing the references just by copying from Quadraple. So we have 0, 5 references starting from 0, 1, 2, 3, 4 and 5. So what is the first function? Minus C. So operator is minus, argument is C. So now we don't have a result field. So we don't have the temporary register. So minus C result will be extracted from the reference 0. So minus C result is stored in 0. So we have to make use of the 0 in the next line. So B into T1. So T1 we don't have in triple. So instead of T1, where is the result of minus C stored? In 0. So we have to make use of that. So here the operator is star and first argument is B, and instead of T1 result is stored in 0. So we have to take up 0. That's all. Similarly next line, again minus C result is not stored in T3, it is stored in 2. Next line, multiplication operator B is to be multiplied with T3. So T3 result is stored in 2. So directly we can write it as 2. Next line, T2 plus T4. T2 result is in 1. So first argument. T4 result is in 3. We have to sum these both. That's all. Now the answer of this addition is stored in 4. So we have to assign that to A. So A we have to assign 4. That's all. That is very simple. In quadruple we will be having the temporary registers, but in triple we don't have temporary register. That is, we don't have the result column. So without results, how we will be extracting the answer is that with the help of the references, that is 0 to 5, we will be extracting the answers and we will be using that in the table. That's all. So indirect triple is that here we will be using this references answer. Actually these are the references where the resultant is being stored. So we will be using the pointers to access these references, that is indirect triple. The same table is used for indirect triple. The only difference is that we will be having another column saying pointer, which points to the references to the answers what we have completed. We can have the pointer some other numbers instead to avoid the confusion. So for 14 to 0.20, 15 to 1 and 16 to 2, something like that. So it just continues. That's all. Thank you.